surfaces are extensions into 3D of your conic sections. So the names of our quadric surfaces are ellipsoids. Spheres are a kind of ellipsoid, okay? So ellipsoids and spheres is one shape. An elliptic paraboloid is the name of another shape. Again, we'll explore these shapes a little bit more. I'm just trying to get us used to the names. And again, the names make sense if you start to realize what the shapes are. So there's a bunch of elliptic paraboloids here. A hyperbolic paraboloid. So again, I put several on there. A cone. And actually, the software has a little bit of trouble actually drawing the cone. The cones do connect at a point. It's just the software, connects points, and so it'll quit drawing here and then connect to the next thing, and it makes it look like it's got like a neck, and it really doesn't. So the software often doesn't do a great job drawing the cones. A hyperboloid in one sheet, that means it's all connected, and we have hyperboloids in two sheets. Okay, so these are the names of the surfaces, and the names come from something. I think an ellipsoid is kind of self-explanatory. So let's look at the form of its equation. The example that I have here the example that we've started with is this one. Notice that x and y and z are all squared and they're all the same sign. They're all the same sign and all squared. Okay, that's an indication of it's a paraboloid. If x and y and z, if all three of them are the same sign and they're all squared, you have an ellipsoid. Your ellipsoid might be a sphere. These numbers down here tell you the breadth or the width of the ellipsoid in that direction. So this ellipsoid has a diameter of 8 in the x direction. Okay, it has a diameter of 8 in the x direction. It has a diameter of 12 in the y direction, and it has a diameter of 6 in the z direction. So where am I getting that? I got 8 from the 4. 4 is the radius in the x direction, so 8 is the diameter in the x direction. 6 is the radius in the y direction, so 12 is its diameter. 3 is the radius in the z direction, so 6 is the diameter in the z direction. And this one is centered, this particular one is centered at the origin. Like with spheres, if I don't have a center at the origin, you'll see it in the terms here. So for example, if my center was at 3 minus 4 and 1, the equation would look like this. Okay, so this one has a center at 3 minus 4, 1. Notice that when I was determining the diameter, the equation is set equal to 1. You could be provided the equation, not the case. I mean, I can multiply both sides by some common denominator and just and not have the fractions represented, but then this would not be the number 1. If it's not in this form, don't try to pick out the diameter in the different directions. If you're trying to pick out the diameter in the different directions, then divide by the appropriate numbers to get the 1 by itself. Also notice these are in the denominator. Okay, so, you know, we could look at some examples where if, you know, you've got a number written out here, make sure you end up looking at it as some number in the denominator squared in order to interpret your radii or diameters in the different directions. Let's look at the elliptic paraboloid, and then I will start to talk a little more about traces. Okay, so if we compare the formula for the elliptic paraboloid with the ellipsoid that we were just talking about, notice 2 of the variables are squared and have the same sign. So x is squared and y is squared, and they both are of the same sign. The third variable is not squared. So if you have 2 of them squared and they're of the same sign, and then the other one is not squared, then you're going to have the shape of an elliptic paraboloid.
Does the third one matter what its sign is?
Well, if it's, I'm going to answer no. If z was negative, then it would just be flipped upside down. So you still get the same shape, it's just flipped upside down. So I'm going to say no from that perspective. Okay, so on that note, let's start to talk about traces, because I don't want you getting too, I mean, if this is your first exposure to this material, these names may sound pretty foreign, and it might be a little bit of a stressful idea to think